Tonight's presentation comes to us from none other than our Vice President, Pat Rundall, and actually an exciting presentation. I've been familiar with and participate, I'll say loosely. I'm on their group list and occasionally swap some emails with the HamSCI folks. HamSCI got started, probably maybe a decade ago. Really getting some cool stuff going and some cool momentum going back in 2017 with the first solar eclipse QSO party. And Pat had the opportunity to get some information from them about some upcoming events that might be going on and might be of interest to everybody. So with that, Pat, we'll let you take it away with your presentation.
Great, thanks, Paul. Do I need to turn this on? Or is it
Oh yeah, great question. Let me just unmute you and mute me. You're good to go.
All right.
Everybody sit okay here in the room. I need to drop one more set of lights. Okay.
I'm going to see if I can do this.
Good enough with that?
I think so. I think it'll work.
Okay.
Thanks, Paul. All right. So everybody in the room is a ham, right? Would anybody say vocationally, anybody in the room is a scientist? Scientist. Okay. Would anybody in the room say they're a space physicist? Okay, I can say whatever I want. That's perfect. All right. Yeah, so this was actually a talk that I attended at the HamCation. So my wife and I went to Orlando in February, just kind of tired of winter, and over a long weekend went to Orlando, and I went to the HamCation is now the second largest annual ham fest. So about 25 to 30,000. So it's creeping up there toward Dayton anymore. But they had a great series of forums, and one of the forums was on HamSCI, which, like Paul, I was always kind of casually, arm length, curious about what this was all about. So I got a lot more details on it. I thought I'd share those with you tonight. I asked the presenter if I could hijack his slides and repurpose them for tonight. And given, sometimes they do these things online and they'll give the presentation remotely. But because of the nature of what's going on, and they got we'll get into that, but a very busy season going on right now with that group. So he said, yeah, no, go ahead and take the slides and do whatever you want. So that's what I've done here. So just a little, my science background. So I was licensed in 1980 at age 12. I was involved with the state science fair as a kid. So I had a couple science fair projects, one on the effects of RF energy on earthworms, mostly 40 meters and 100 watts in my dad's winemaking kit, with some really cool X-ray film that you used to be able to buy from Kodak, and you could take pictures of the earthworms heating up as I exposed them to 40 meter CW. And then I had one that I proposed that was going to go to Rockwell Collins on a method to come up with locating black boxes if an airplane had gone down. And I had one other that was deemed unethical, that I'm not allowed to, it got shot down. And it was unethical in hindsight, but we won't go into that tonight. I liked to mess around with antenna designs as a kid, and then got involved with a solar car, the first ISU solar car, and got my EE degree from Iowa State, and then undergrad, and then worked for Motorola GSM, working on the first digital cellular infrastructure. And ever since, I've kind of drifted away from science professionally and worked more on software systems and whatnot. So it's kind of cool to me. I think, you can look at the realm of science. So there's scientists that focus on discovering new knowledge, testing hypotheses, and understanding those underlying laws that govern some natural phenomena. And then there's also engineers who, much like hams, I would say, focus on applying these laws to solve some real world problems. and they work on solving practical problems and creating practical solutions. So you guys could probably think of about 1 million examples of this in the ham radio world, where it's great to know the science, and some of this is covered in your licensing exams and Ohm's law and all of that stuff. But really, Ohm's law is interesting, but that doesn't necessarily help me make a QSO. So you think of the practical real world things that you do as kind of with your engineering hat on as a ham to address those questions and just get the job done, sort of is the idea. And what I like to think is this HamSCI concept is kind of the intersection of those two schools of thought. So we'll give an example here in a bit, and it touches on this organization. So the Ham Radio Science Citizen Investigation Group, that's where this HamSCI collective name comes from. It was founded by this fellow down here in the lower left, W2NAF, Nathaniel Frizzle. He's currently a professor at the University of Scranton, a physicist, but he he's well published, has his doctorate, and fairly well known in, I think, ionospheric research. We'll put it that way. But really, this all kind of bubbled up in about 2017. So I think 2017 was the year of what they called the Great American Solar Eclipse. And the reason it was called that, it was a major event, and it was because the totality of the eclipse went from coast to coast. I think it went from Oregon to, do you remember, Ron? Somewhere on the East Coast. Yeah, it was and my wife and I and daughter, we drove down to Missouri to see it, and it was kind of a big deal, but a lot of people were really interested in it because it was the first time it had happened in quite a while. And so some really cool things happened that are kind of the convergence of a number of things happening all at the same time. So you've got this guy who's interested in radio propagation, and he happens to be a ham, but he's a physicist. So he's off here in the science world, and he's studying the ionosphere. At the same time, think about what had been happening in the radio world. So in the radio world, SDR radios are coming around, and SDR radios have capabilities to do things like monitor an entire spectrum or a very broad band at the same time. And then weak signal propagation tools like WSJT and the FT8 and FT4, and some of these protocols were being developed. And in the contesting world for CW and RTTY, there were skimmers that were able to receive and decode the entire spectrum all at once. If you've ever seen one of these tools that can, they're really cool, but it can watch an entire band or multiple bands, see all the signals come in, process them, decode them, assign a signal strength to each thing that's coming around. So, and then aggregate all that data and push it up somewhere and store it so that people can query it and study it. So all of these things were happening at a kind of within a span of 15 years or so. And W2NAF, Nathaniel said, wouldn't it be great if we could kind of push all this together and start to study the ionosphere using all of the convergence of all of these things? So that's kind of what led to what we've got today. So why solar eclipses? So you probably know that humankind has always been fascinated by solar eclipses. And over, different cultures and generations, there's been fear and ignorance that's led to a lot of interesting theories about why eclipses have come about. The ancient Chinese thought that a dragon was eating the sun during an eclipse, and they would beat drums and pans to try to scare the dragon away. And there was a common theme among some of these ancient cultures who felt that various groups of animals were involved in chasing the sun and moon across the sky. And the animals would occasionally catch and eat the sun or moon, making them disappear until they regenerated. So I guess all that to say, mankind has sort of been fascinated with eclipses for a while. And even centuries ago, so when astrologers were tasked with predicting eclipses, there would be a case of if you predicted incorrectly, you would just be executed. And then even in modern times, eclipse predictions today are much more accurate. No one's life's at risk, but accurate predictions can allow us to plan studies of eclipse-related phenomena years in advance. So we know, for example, when the next eclipse will be. Total eclipse in the United States. Does anybody know? Paul, anybody besides Paul know? You guys know? April 8th. That's right. So, wow, that's awesome. So the next one's coming up. And because it's coming up, we can say, we can take a look back at past events, but the next one we can plan for what we're going to talk about as the big radio event that we're going to do as a group of hams to try to study the eclipse, and we'll talk about that. All right, guys, know that when the next one is. When's the next one after that? Total eclipse in the United States. What? When? I thought it was 2040, but
yeah, it's a ways out.
It's a ways out.
Yeah.
So this is like an opportunity. Eclipses are relatively rare. We've just had a kind of a flurry of them, and now we're not going to see one in the US for quite a while. So it will not be a total eclipse here in Ames. Ron says 82%. We'll see if he's right. That's right. That's right. Sorry, Ron. That's what you get for making a prediction. Don't blame the internet. All right, so if you don't know what an eclipse is, it's basically when the moon, at least a solar eclipse, is the moon casting a shadow, and then you can result in two parts. One part is the area of totality where you cannot, it's effectively nighttime, but there's a pretty broad gray area, sunset-y, that's not going to have the total eclipse effect. And so that will be us at the next one. 2024. Oh, so this will be when the moon is at or near perigee, so it's closest to the Earth. So this will be an interesting one from that perspective then too.
That results
A bigger shadow. Right. Yep. Yep. All right. So this HamSCI group is now beginning to report observations from the 2023 eclipse. So this was as of February. They were still collecting data from the radio event that happened in, what was it, last October?
Yes.
Yeah. And so there's the path of the October eclipse, and then the April one on April 8th you can see it'll cross Texas and go on up to Maine. We'll have decent, you'll be able to tell that there's something going on here. Anybody know what day of the week it'll be? It'll be a Monday. So you may have to take the day off of work. 2 days off of work if you're going to travel somewhere and do something fun. Yeah. So the HamSCI group is studying how these two eclipses will affect the ionosphere. And again, they're collecting tons of data in order to make that happen. All right, so a lot of what they're trying to do through HamSCI is study the ionosphere. And when you took your radio license exams, I don't know so much for technician, but certainly for general and extra, there were most likely questions about the ionosphere on the exams. Who can tell me what the layers of the ionosphere are? D, E, F1 and F2. What do they all do? D is a very absorbing layer of the ionosphere. And what do we know about E? Anything exciting about E? It's sporadic. That's where you get the propagation mode known as sporadic E. The 6 meter band, sporadic E, and 2 meters even can get sporadic E propagation, which is interesting. Hard to predict, but. And then what's the deal with F? DX, yeah.
They separate during the day. That's
Yeah.
F1, F2 at night. They tend to start to.
There you go. So D being closer to the ground, and then it goes higher and higher. And as Paul said, F actually splits, and D and E combine at night as well. You know, for somebody that doesn't, like I was explaining this to a guy at lunch today at work, and you know, and he's actually really interested in getting his license. So this guy is kind of like kicking the tires on ham radio, but fascinated with this stuff. And I said, you know, very simply, think of WHO radio. WHO radio, I can hop in my car, I can drive to Florida in the middle of the night, in the winter, I can turn on my radio in the car and I can hear WHO radio. So why can I hear WHO radio, but I can't hear, you know, an FM station 103.3 FM? Why do I not hear that in Florida? Well, different modulation type, right? So it's FM, that's part of the story, but maybe a bigger part of the story is that at 100 megahertz, it's much more line of sight, VHF type operation. And rather than refracting off of the ionospheric layers, those signals just simply penetrate straight through. The WHO type signals can actually refract off the ionosphere, that what's left of it at night. But the D layer during the day is so energized that it absorbs all of that WHO signal. So it doesn't get the chance of refracting off the ionosphere. So, so it's just an interesting phenomena that's always kind of fascinated me, even as a kid. And, you know, that's one of the things that will be studied during the eclipse. Yeah, so, you know, as you might expect, when that shadow of the moon crosses across North America during the eclipse, it's kind of like a simulation of turning into nighttime and then daytime again as that shadow comes through and passes. And so radio-wise, you might predict a similar type of response. There are some differences that you might think of between an eclipse and our normal transition that you would have from day to night. The eclipse night, when you see an eclipse, is obviously much shorter than you would have during a nighttime. So you have a very short window as opposed to a regular night. It's much more localized because you saw the spread going across North America. And it's caused by the moon traveling at supersonic speeds rather than the rotation of the Earth. And it travels in a different direction than our normal day-night transition. So there's a few differences. But the science-y folks like to think of this as a mechanism for a controlled experiment. So apart from the dusk to dawn to dusk and the seasonal differences, there are a few other things that are a bunch of inputs to the upper atmosphere that you really need to take into consideration when thinking of this as a controlled experiment. So there might be solar flares, there might be geomagnetic storms or other space weather events that'll be other variables sort of thrown into this controlled experiment that will be run with the eclipse. So we can't really technically say that this science conducted on this solar eclipse through radio traffic is a purely controlled experiment, but it will generate a ton of data that can be studied, and then we can put some theories across this data and see how close we are to any hypothesis that somebody may generate. So pause there. Here's what the eclipse will look like in April. So you can see the normal gray line path of the sun, and here comes the eclipse across Texas, and then sweeping out into the Atlantic. Yeah, any questions about the path of the eclipse? High-tech animation here. It's kind of cool. For PowerPoint, I kind of wonder how they did it. If I get off that slide. All right. So the what they're calling the festivals of eclipse ionospheric science, FOEIS events. There's actually 6 separate things going on during the eclipse that they'll be testing for and conducting studies. So the first and probably the biggest and most well-known is the QSO party. And we'll get into the details of that in a minute here. The second is what's called the Gladstone Signal Spotting Challenge, or GSSC, which is named after one of the founders. And the third one is kind of interesting. It's build and install a GRAPE personal space weather station. Talk about that in a minute. Fourth, there's an experiment that's going on to look at the ionospheric layer heights using time delay of arrival events. Fifth is a medium wave band recordings of AM broadcast stations. So they'll just be receiving these AM broadcast stations. So seeing how that's impacted propagation wise. And then the last one is related to VLF studies of the 630 meter band and the 2200 meter band and lower bands. So these guys that are kind of crazy that experiment with those very long wavelength, low band operations. All right, let's start with the QSO party and all of that. For the QSO party, does everybody know what a QSO party is? Anybody never participated in a QSO party? Has everybody participated in one before? Yeah. Yeah, so this will be very similar. I like how he explains it to people who don't know, and he's given this talk actually to other scientific communities and astronomy groups and other people who might be interested in science. And he explains it to others as this is ham radio's version of a cocktail party in a really, really big room, potentially the whole Earth. And I suppose if I was going to describe it to somebody, that's about as good a description as any. But for the hams, this is an event that welcomes CW, sideband, and FT4 and FT8 QSOs. And all of the popular contesting software should directly support the QSO party. It's a pretty simple exchange. And the logging and spot data that comes out of that event is then fed in and aggregated, and that's what they use to do their scientific research on the ionosphere. And how they get there, we'll talk about here in a minute. So just in terms of it being an event, here's kind of some of the rules and basics that you may want to know. So this is all bands from 6 meters to 160 meters, and like most other contests, all other contests, excludes the WARC bands, so nothing on 60 meters, 30 meters, 17 meters, 12 meters. And again, using CW sideband and the digital modes. Their website is sort of the ultimate resource for the rule set for this, so it's really easy to find. If you go to HamSCI.org, there's a menu there that you can navigate to get to the rules for the contest, and there's certificates available for anybody who participates. So it's much like the Iowa QSO party in that it's easy to participate, easy to get a certificate once you've uploaded your log, and get involved. The results will be published. I think I don't know if the October version had 500 participants or the one before that, but they're getting to have some pretty good numbers involved with these events. So that's the QSO party. The second event, or the second piece of what's being studied through the eclipse, will be the Gladstone Signal Spotting Challenge. And so the idea here is for anybody to transmit or receive WSPR, the Weak Signal Propagation Reporter, or FST4W. I've never used FST4W. Has anybody ever used that mode? I think you have to go into a special settings to set that up in WSJT. But this weak signal mode that was developed by Joe W1JT Joe Taylor, is extremely useful for doing what they want to accomplish here. It's extremely useful because you know where the person was that received it. So they'll capture their Maidenhead grid and they'll know geographically where he's at. And then for everybody that he hears, they'll have the incoming signal strength and report recorded. So think about we'll know how many dBs we heard them, and the signal to noise is all captured and all of that stuff. And then they can combine all this data together to do their study using WhisperNet, I think, is their data source for the WSPR folks. Really, the equipment needed to be a part of this Gladstone challenge is pretty simple. Definitely don't need racks full of gear. And they show a picture here of a Raspberry Pi based WSPR transmitter. And yeah, let's go on to, there we go, the GRAPE Personal Space Weather Station. So this project is the idea here is to build this GRAPE receiver mixer. And it really does one thing. So it's tuned to WWV. And so it's listening for WWV, the signal, and any deviation from the standard that WWV should be at. So if you're listening to the 10 megahertz version of WWV in Fort Collins, Colorado, I believe, they want to make sure that it is precisely on 10.00000 megahertz, not deviating. Or there's a 15 megahertz version, and I don't remember all the others, but they're looking for any drift. So drift is actually caused by the Doppler shift or Doppler effect that could be monitored as the eclipse passes. And yeah, there are things that they want to study related to that helps inform them of the size and shape of the eclipse itself. They had the last time they ran this test, they got several of these, and the GRAPE actually is an acronym that stands for something. It's the Great Radio Amateur something experiment, propagation experiment maybe. And the last time they ran this, one of the issues they had was they really didn't have very many of these receivers set up in the Midwest. So they had a ton of them on the East Coast, but now they'd really like to get some that are a little bit further out. So if anybody's interested in pursuing one of these, probably better get on it. They said the kit isn't too difficult to build, but there was actually a group that got together that built a bunch of them and sent a bunch out. So you may be able to get an assembled one if they're not already all taken. Yeah, so you can get a full explanation of the GRAPE experiment. That's kind of beyond what we're going to talk about here tonight. But yeah, in the simplest terms, really what they're looking at is the way that the sun affects the ionosphere And essentially, we can sense the bottom side of the ionosphere, that lowest area upon which the actual refraction occurs, by measuring the deviation down to millihertz precision, the drift of WWV. So kind of an interesting thing there. Mm-hmm. Right. Yeah. Interesting stuff. Does anybody ever participated with the GRAPE project? No. I was thinking about your balloon tracking thing. Kind of a similar thing. Like you've got a receiver that's doing that. They would love to have a GRAPE receiver here in the Midwest doing something similar. So that's that one. The next one is the time delay of arrival event. And so if you'd like to be a part of a controlled experiment here, really what they're looking at is there's a transmit receive of a chirp signal that's custom generated for your station and call sign during the eclipse. And through this, they'll measure changes in the F2 layer height as the eclipse impacts the ionosphere. Yeah, I think it's, I don't quite understand all the science behind it, other than there's a time delay going from this station to the other station when you skip across the F2 layer versus just a single hop off the F2 layer. And the delta between those gives you because one takes a longer amount of time than the other, the difference between those two times helps you run a calculation to calculate that layer height. Klaus is willing to give any explanation that's deeper than that. Thanks, Klaus. So in summary, basically this FO Festival of Eclipse experiments is meant to be a fun event. So getting people involved with the eclipse and getting involved with science to a degree and ham radio all kind of thrown together. And but it's kind of got a purpose too. Ultimately, the pitch is that it's going to help us collectively have a better understanding of HF propagation, improved models of the ionosphere, and improved propagation forecasts. So with all of that said, what did we learn from the recent October eclipse? So from the October 2023 eclipse, the team said we're prepared to discuss some observations, but not findings. So we can talk about what we witnessed as we ran this experiment, but we don't know yet enough to say we can come to conclusions on why we saw what we saw. So as you can imagine, there's mountains of data to go through, literally terabytes and terabytes of logs that were collected, information that was collected, everything that gets set up to the WhisperNet or anything related to PSK, FT8, FT4, all of those digital modes. That data is all aggregated and collected and analyzed. CW-wise, all of that data goes to the RBN, the Reverse Beacon Network. And the Reverse Beacon Network, is everybody familiar with the Reverse Beacon Network? Vaguely. So the idea with the Reverse Beacon Network, so you can think, maybe it's best to explain it through a little bit of the history. So if you go back to the 1970s, where guys were doing a lot of CW contesting, you know, you might be making a lot of contacts and doing okay. But if you stumbled upon a new multiplier in the contest that was going to give you a lot of points, you might want to tell your buddies about that multiplier. That might mean picking up a HT and telling somebody on the repeater, hey, tune to this frequency and you'll find Russia and you'll get a multiplier for that contact. But eventually, as packet radio came around, guys would send it to each other on a packet on a computer in the corner. that system evolved to going out over the internet, lots and lots of data going around. And then the next evolution was software-defined radios, collectively listening to all frequencies all the time, all through the whole contest, decoding all of that CW through software-defined radios that are sprinkled around the world, and then aggregating that and throwing that up on the internet. And so now there's mountains of data that literally you can find logs of. If you went back and looked at my CW contacts 5 field days ago, you could go see all of that buried in the logs there that are just floating out around the internet. So that's a lot of data to sort through. So from the most recent Eclipse, there's still people going through the data and trying to see what we can learn from that. They've actually hired a postdoc employee at Scranton University to go through the data. So lots of data. And so they'll be studying that for a while, and they expect that there will be findings that will come later this year, some in next year, and some for years to come. However, there's a couple things we can look at. Here's evidence from the grape receiver experiment of the reaction of the eclipse, the ionosphere's reaction to the eclipse. And just to note that it's a similar reaction that you see in this part of the graph to what you see when dawn occurs. So when dawn occurs, it's a pretty abrupt and very powerful, like eruption of energy. Similar, you see it a little bit here in the eclipse as the sun comes back into view again. They did some comparisons on the medium wave reception observations. I don't know if I could quite compare that enough to see exactly what's going on, but they says not all of our observations involve the ham bands or even transmitting. Here are graphs of signal strength from monitoring AM broadcast station KKXA in Snohomish, Washington. On the control day, October 13th, you can see how the signal steadily weakened after the sunrise. The graph looks much different on an eclipse day. The signals grew in strength as the eclipse passed over the western US, a brief period of darkness which caused the signals to dramatically peak. So you might think of WHO radio and that D layer absorbing the signal during a normal day, but now you've got an eclipse in the mix, and so the signal will come back up again after, kind of in darkness through the eclipse. So kind of an interesting observation there. So they're really looking for, through this event of the eclipse, let's go back to the solar eclipse QSO party in particular, but beyond that, anybody that's willing to set up receivers and participate as well. They're looking for lots and lots of participants because the more data points they can collect, the better. Whether that's operating in the QSO party or any of these other things as well. There have been quite a few publications that have resulted from this research. So, and by the way, this research is endorsed by and fully backed by NASA, NIST, the National Science Foundation. There's a number of research-focused groups that are very interested in the results of the solar eclipse ham work. Yeah, any questions for Klaus? Skip.
Okay. And on the right-hand building, it says WAEDU.
Yeah, do you know him?
Yeah.
That's the Ohio State Club?
That case.
That's Case Western.
Case Western Club.
Yeah, that I have operated from that station,
Wow.
but the sun was out when I was operating.
Oh, there you go.
But they're on a hill, and they're kind of in the penthouse. Penthouse is a relative term of a 6-story building. And so they have a pretty good setup.
Mm.
So I'm glad to see that they're getting some mentoring.
Yeah, I don't know how they made it onto that
They're,
slide,
they're
but
actually very active in the HamSCI group.
are they?
Yeah, there's several folks that are at Case Western that are active participants in the HamSCI. I think Grape is actually headed up by someone at, if memory serves, at Case Western. They're also involved with the Tangerine SDR project
Right.
as well.
Now that you mentioned that, there were about a half a dozen colleges and universities that were very much into the HamSCI effort, and didn't see Iowa State on there, but what are you going to do? Any other questions? Uh,
1 o'clock's totality, give or take, in kind of Missouri.
It's at night.
It's at night.
It's a night.
And I've been looking to further down towards Arkansas, so that's probably where my timing is.
Yeah. I was gonna see if I could tell from this.
You just got to hit pause at the right time.
I know I did, and it, right about there, about 1830 UTC. So about 1830 UTC, Jeff.
And there are some great resources online for anyone that wants, that's
There's an
interested.
app that I got when it came through in 2017 for my phone that'll do a countdown and like all this stuff to basically figures out where you're at.
I can give you info on that too.
You got the same app?
Maybe.
There's people that you can pay to come give you, like, a guided tour through the eclipse. You can buy the app.
A guided tour through the eclipse?
Yes, you could pay people, like, you could join this group and go stand in this, this big field.
Oh.
They're gonna have like a speaker, like a scientist talking on a speaker.
It's like tornado.
If you're really interested, there's a couple flights you can book that are commercial airlines. There's one, at least one I know of, maybe two that leave from, I think, Houston,
Austin.
Austin, and they follow it to the East Coast.
Yeah, I think it's Austin to Columbus.
That would be fun. Yeah.
I think it was Delta that was doing that. Solar Eclipse Timer is the app that I use.
Yeah.
It's $1.99 for each eclipse. It's the same app as before, but you pay $2. It was phenomenal because it tells you at each phase things to look for.
Right.
There's a whole lot of phenomena around solar eclipses.
Yeah.
That even beyond the radio aspects are pretty.
Yeah, when we in 2017 drove down to Missouri to see the big one, I was kind of thinking, is this going to be worth it, or is this what is this? And then you get down there, and it was cool because it was like, at the moment it was happening, it was like sunset 360 degrees around. What in the world? It was really neat. So then our next discussion was, when's the next one? When can we do this again? So
That sounds familiar.
yeah.
I'm going to stand by you because you're going to talk about it a little bit.
Oh, yeah, we ended up in western Nebraska because we wanted to be guaranteed clear skies, so we drove all the way out there. We didn't have to go past Lincoln, but we just kept going. And so we literally had, like, on the way home, it was all planning the next one. And so, yeah, that's happening.
Well, mention the radio piece too.
Oh, yeah. So we had planned on doing the QSO party. We set up.
We had a 1x1.
Yeah.
Oh, yeah.
Yeah, we had the radio set up, the wire was in the tree, we were making a few contacts, and then, partial eclipse started, and we sort of set the microphone down and nobody touched it for like 3 hours.
Because you're all
'Cause we were
just
in awe.
dumbfounded by the eclipse.
Yeah.
Yeah.
Just standing there with our mouths hanging open. And so we didn't touch the radio at all. So this year, we're just gonna run a whisper beacon
Yeah.
at the site. We're in totality and just set it and forget it.
So you guys will be somewhere that is in totality?
Yes,
We will.
with
Yep.
clear skies, unless they aren't on anywhere in the US.
So where will you be?
We don't know.
Yeah.
Oh.
Ask me that Monday morning.
Probably somewhere between Indiana and North Texas.
So Indiana will be in totality?
Yeah, it goes right over the top of Indianapolis, Dallas, Fort Worth, kind of draw a line between those two.
Man,
So we're hitting St. Louis the day before and then looking at cloud cover forecast to decide whether we go northeast or southwest.
That was
And Missouri had cloud cover or high chance of cloud cover, and so we ended up in Nebraska.
are you sure you're going to be far enough south? Oh, Indianapolis might be.
Indianapolis actually has totality.
Okay. And just to be clear, you do not have to be in an area that's within the totality in order to participate. They, in fact, they want people in South America. They want people from all over the place to be participate in this, because all of those data points from all of the locations really help make the data research work. As a part of the QSO party, there's bonus points too if you are interested in kind of pursuing it for the awards, where you can, if you operate from a park or in a public place, or if you do different things, I think you can get points for observing the eclipse. But just, yeah, just to make it fun, chance to get out.
Yeah, for the QSO part, I think the best data will come from the FT modes, FT4 and FT8.
And CW,
What?
and CW,
No,
yeah.
because the FT modes give an automatic signal report. With CW, you have to rely on the operator.
No, because of the RBN. So the RBN collects the data for CW that has a signal report with it.
FT modes are two-way. You get the signal report on both ends.
I suppose.
So you
Yeah,
get more data.
yeah.
Anyway,
whisper's better.
Yeah, it's all the bands. Any other questions for Pat or Klaus,
Or Klaus, especially Klaus.
especially Klaus? Any questions online? Just go ahead and speak up.
Thanks, everybody.
Going once, going twice. Thank you, Pat. Awesome presentation and a great introduction here to HamSCI. I first really kind of got, I'll say, more interested with them after attending one of their presentations at Dayton in 2019. We had a chance to get over to the Tapper. Yeah, it was a Tapper AMSAT banquet is what it was. And Phil Erickson, who's affiliated with the HamSCI group and has now been promoted to, I think he's chief of the MIT Haystack Observatory, that is the radio science observatory at MIT, was the presenter or the keynote speaker. And it was fascinating to listen to him talking about citizen science and really how we as amateurs, I think, and citizens together, but we kind of, you showed it real well, Pat, I think in your chart there that, second or third slide in, that we discount ourselves that we're not scientists, and yet we're out there and experiencing, and we've got knowledge and we've got the ability to take our observations, collect them, and present data that then becomes very valuable in understanding phenomena that we experience,
Right.
but we don't fully understand. So just great opportunities there. So, and they're doing all kinds of cool stuff. If you're interested, hit their website. I would encourage everybody to do that. They've got specific Google groups for different stuff. Like I say, I'm on Grape and a couple of the others. It's been fun watching them build these devices, design them, and get them out there.